First, I would like to tell some regularities for the participants that from wherever country you are joining. I can see that there are participants from apart from Bangladesh as well. There are some international participants. So we would conduct this whole webinar in English as our official language. So please keep your mic muted during this session. Please let us know in the chat box from which country you are joining with us today. And if you are from Bangladesh, let us know from which university you are joining in the chat box. At the end, at the middle of the session, there will be a Google form which you participants have to fill up for the e-certificates. And at the very end of the session, there will be a short question answer session where you can ask your questions. So with further ado, I would like to request Dr. Mohammad Ashraful Haq sir to inaugurate the webinar and say a few words. Ashraf sir, the floor is yours.
Okay. Assalamu alaikum. Am I audible?
Yes,
and
sir,
also
clearly
visible?
audible.
And also
Yes, sir.
visible? Okay, thank you very much. My dear colleague, Dr. Shagor, Rakibul Hassan Shagor, he is the you are associate coordinator or coordinator of IEEE Student Branch. And also our honorable speaker, Dr. Taskin Jamal, he is also my direct student. And I taught him just when I joined in 2007, they are my first students. And I was also very shaky that time. And I used to ask them how I can teach you, which will be the way that I can teach you so that you can learn something. So they informed me that, sir, you just teach us and use the board all the time. So we will be able to learn everything. The IUTian can learn anything within 2 or 3 days. You don't worry. You just teach us. So I know that the IUTians are very, very smart and they're very talented. They can pick up anything very quickly. And internationally, they're very recognized. And that is the example of Dr. Taskin Jamal. And you have already seen that he is IEEE fellow, and also he is very, very in a good position of IEEE in the smart grid system. So, in the smart grid system, power electronics actually is one part. So by controlling different type of devices and also the controlling of the power. So the power flow, either out or in, it has to be economic. That is the main objective of the smart grid system. And you know that grid system. In Bangladesh, we have the grid system. We have some of the power stations. The most of the, the gas. We're burning the gas and boiler. We call it steam turbine based. And also we have Kaptai, the hydroelectric. And now we have some rental. And they are providing all the power to the grid. And also we purchase some power from India. They are also coming to the grid. And government also thinking to get power from Nepal, because Bhutan and Nepal, they have a lot of hydroelectric power. So, and also nowadays the renewable energy is the most attractive things. And you know that these fossil fuels are now being almost, it will be finished. They're expecting, or they are afraid that it will be finished within 20, 30 years. Although I don't know whether you have seen in the Facebook or not, in Bangladesh, under the sea, we have a lot of gas that is reserved, and Bangladesh should run this one another 50 years, and we have a lot of minerals. And that is why I think all the international community, they have a lot of attraction about Bangladesh. I think Taskin Kamal, Dr. Taskin Kamal, he knows all these things very much, and he will give you very, very interesting way to understand the first grid system, then the smart grid system, and definitely it will be very much beneficial to our students as well as all other participants from other universities, if there are any. And also, if there are other, I expect that there should be some people from the CSE as well, because nowadays the software-based things are much more attractive, and you know that people are working day and night to make all these things. And you know that even when I was a student, as a PhD student in 91, 92, 93, I saw in Canada. So there is only one engineer in a control room, and he is controlling everything. So you don't need many engineers to go there. You can detect the fault, you can detect the controller for all those things. So this is very nice initiative by IEEE student branch of IUT, and also IEEE Robotics and Automation Society. They are managing these things, and this is this means that IUT is not. When I joined in 2007, it is not like this now. It is much more advanced, and nowadays a lot of guardians are now attracted to send their students, their sons and daughters to this university, and because our teachers are very dedicated, and also we try to keep our university politics free, and also we try to keep our session in 3 years and 9 months, although because of Corona we are a little behind, but we are trying to make it up. So I am talking too much today because my student is in front. So I hope all of you will enjoy it, and in the name of Allah subhanahu wa ta'ala, I formally inaugurate this session. I hope all of you will enjoy it. Thank you very much.
Thank you, sir. Thank you, Ashraf, sir, for your kind words. And now, with the official inauguration done, I would like to introduce Dr. Taskin Jamal for a short bio. So it would be pleasant if I read out the bio of Dr. Taskin Jamal, so that everyone has a good understanding of what he is specialized in. So Dr. Taskin Jamal is an assistant professor currently serving at Ahsanullah University of Science and Technology at the Department of Electrical and Electronic Engineering. He received his PhD in Renewable Energy in 2019 from Murdoch University, Australia, and Masters in Energy in 2012 from Asian Institute of Technology, AIT, Thailand, achieving the Best Student Award. His undergraduate degree is in electrical and electronic engineering from Islamic University of Technology, IUT Bangladesh. Due to his vivid academic career throughout his student life, he was awarded with many scholarships, which include IUT OIC Scholarship, Japanese Government Scholarship, KF UPM Scholarship, IPRS, and APS scholarships. In Australia, he was also awarded with few IEEE grants to present his research works in prestigious IEEE conferences. Dr. Taskin was the Australian national finalist in the first ever Climate Launchpad organized by Climate KIC Australia. He has a vast collaborative research, teaching, and consultation experience in the fields of renewable energy and electrical power systems since 2019. He has in his name a good number of research articles published in reputed international journals and conference proceedings. He is serving as an editor and reviewer of many high impact factor journals and as a technical committee member of many reputed conferences worldwide. Over the last 10 years, he has taught in different universities in Australia, Bangladesh, Saudi Arab, and Thailand. He's also a senior member of IEEE Power and Energy Society and Electrical Energy Society of Australia. He was elected as the chairperson of IEEE Murdoch University Student Branch in 2016. And not but the least, he is also a founding member of IEEE IUT Student Branch. So, and last of all, his hobby includes extreme sports, traveling, nature, and nature photography. So I would like to give the floor to Dr. Taskin Jamal, sir, for his presentation today. Sir, if you are there, you can begin. Thank you.
Thank you very much for very cordial gesture. And thank you to IUT IEEE Student Branch for inviting me to this very nice presentation session. And I am feeling honored to be here among my junior fellows, among my direct teachers and all well-wishers. And it's a privilege for me to present something in front of my direct teacher. And Professor Ashraf sir was my not only a direct teacher in the classroom, he was my thesis supervisor as well. And also he attended my wedding ceremony. So I was in very good touch with him before I went abroad. And finally, with his dua and prayers, definitely I am in this position today. Without his blessings and without the blessings of all my IUT teachers, it wouldn't have been possible for me to come to this stage where I am in a position to present something as a keynote speaker in IUT. So thank you very much once again for inviting me as a speaker here in this program. And also thank you, Shagor Bhaiya. I found him as a senior Bhaiya in my when I was there in the campus. So from then on, we are in touch. So it's been like around 15 years. We know each other for allowing me to present here. And thank you, students, for joining this session. When I will be presenting, I'll try to keep things simple because there are lots of students from third year, fourth year, and also non-background students may be there because smart grid is a very booming topic and booming subject. I prepared for last 2 to 3 days these contents because there are lots of things regarding smart grid in the web. So, finding out the crucial information and disseminating to you in context of Bangladesh was a very, very difficult task for me. And energy sector is a sensible sector, and it's a very secured sector. We all know in any country. So not all the information are out and open regarding your policy and your strategies, and sometimes some data the government do not want to keep it open for public. So I will try my best from the data that I got through web searching and through my experience and so far knowledge, try to disseminate you the overall view of what is a smart grid and why Bangladesh should adopt this technology, and finally some policy recommendations and some ideas I would like to share. And if you have any questions regarding anything, please write in the comment box so we can take the questions after we are done. I'll now try to share the screen. Let's see. Okay, so I'd just like to know which screen are you seeing, only the slide or including the notes and everything?
Sir, we can see the notes as well.
Okay, so let me change this one. Is it fine now? The whole slide?
Yes, sir, it's fine now.
Okay. Thank you very much once again. So the topic of today's presentation is smart grid status and prospects in Bangladesh. And I am Taskin Jamal, as the introducer has already introduced myself. So I'm very much honored to present here in front of you. So my presentation will cover some interesting things today, how the transition has been occurring and what we call a smart grid. I mean, the smart grid definition. Then I would like to highlight on the conceptual model of smart grid, some of the features. Then I'd like to showcase some of the research outcomes, not too many, because I tried to make it generalized. So some research outcomes regarding the smart grid and smart appliances and those things. And finally, lots of slides regarding Bangladesh smart grid, what is the current status, what could be done, and the prospects as well. And finally, I'll end it with some concluding remarks. So here, the first one, I'm sitting in front of you. I'm presenting something. My computer is turned on. I have a glass of coffee in my hand. So I'm kind of like relaxing and maybe listening to this presentation. So you are already a part of the grid now, because everyone asks from the non-technical background, what is an electric grid? So few hundred years ago, I shouldn't say few hundred years ago, even like 30, 40, 50 years ago, people used to say electric grid means only the generation, transmission, and distribution system up to your customer premise. But now the customer is also included within this grid infrastructure, or what we can see, or what we can say the concept, the overall concept. Because we are getting the electricity from the grid, we are utilizing the electricity to see this monitor and this wonderful presentation. And also in return, we are paying to the generation company through the transmission and distribution operators and something like that. So there's a specific mechanism how the money flows within the system, and then the generator will be benefited, or he will make some profit by generating the electricity. So it's a big system where the generation, transmission, distribution, and the customer, everyone will have cooperative effect. So how the transition actually occurred, like when we say smart grid, that means there is something called grid, which I just explained now, and then we have a smart grid. So what makes it smart? So if we look at the figure, on the left-hand side, the past system, which was kind of like a one-way flow of electricity. We had electric generation stations, some substations. Then we had many, I think only limited transmission and distribution network, where lots of countries didn't have access. The people in different countries, they didn't have access to electricity, so it was very limited capacity. And then it went to the customer premise, residential, be it industrial or commercial. And how the substations were, in touch with them. Let's say something happened in between the customer and generator, they had to call each other through the telephone lines or something like that. So that was the past system. Then eventually we had, industrial revolutions and lots of things and modern stuffs came into the action. And then we have the present system, where now we have computers and the control center concepts. We have some kind of communication channels established, and then we try to communicate through these computerized systems. And we are trying to integrate some renewable resources, because last maybe 20-30 years we have realized that it's already too late. We have created lots of damage to the earth, and it's causing the climate change issues, global warming, and lots of things. So we have to be very careful. So we are now more concerned about renewable energy resources. So renewable energy resources are integrated into the system, and it's kind of like feeding in the electricity to the customers. In many of the countries, I should say maximum of the countries, still they don't have renewable energy resources built on top of their roof, or maybe they have their own system. So I'm trying to say that even in Bangladesh, maximum of the customers fall into this criteria, that we don't have any own resources, be it a renewable, be it fossil fuel based. And when we call about smart system, that is the future thing. We are looking into the future. So then we have a complex network. So why it's complex? Because lots of things are now coming into play. We have renewable energy resources. Not only renewable energy resources, renewables are basically trying to displace these fossil fuel resources. So lots of renewables, and the intermittent renewables are coming. So there are lots of challenges coming from these renewable energy resources. We have issues about excess electricity generation from renewables. We have shortage of electricity. So here comes the concept of energy storage. Then the customer have become already smart, because they are using smartphone already with lots of functionalities. So when we have renewable energy resources, so why shouldn't I get one? So when you own a renewable energy resource and then you find that you can sell it to the grid. So the grid has to, grasp your extra energy. So now the system becomes complex. So this complexity basically gives you the idea that, okay, we need now lots of bidirectional and multidirectional system, and everything has to be coordinated and controlled. So everything has to be computerized, because the system becomes so much complex that the people cannot manually handle it. So considering all these things, I tried to, put all these things in a table, like what we used to do during our undergrad studies. When we studied lots of things, we tried to make a note. So this is what I made today for maybe some IUTN students can be helped by this table if you work on smart grid. So these are different types of characteristics I found in the electric power network. So in today's grid, we have a one-way power flow mechanism. Generally, I'm speaking about generally, because in Bangladesh, we still don't have any bidirectional flow. But what could be achieved that we are talking about now, that in future when our grid will be smart and lots of things will be there, so that will be multidirectional. The communication is currently now one way, and it will be bidirectional, because customer would like to know something from the utility immediately, and at the same time utility would like to respond to the customer's query immediately. So it requires a bidirectional flow. Customer interaction is very limited these days, because we don't have any ways to complain that I don't love DPDC, I don't love DESCO, so I'd like to change to someone else. We don't have that luxury. So we have a very limited interaction to the utility, and DPDC and DESCO being the utilities in Dhaka city, they know that it's their business and they can play the monopoly. But when you talk about smart grid, you have lots of choices. So when there are lots of choices and competition occurs, your voice is heard. Your voice is basically, I should say, given emphasis on. So this is one of the most important things that we can achieve through smart grid. Then system operation. Now we have lots of manual operations, and in future that will be automated, self-healing and resilient system. Currently, we have maximum of the cases centralized system of electricity generation, and in future there will be centralized, but there will be lots of distributed generations as well to increase the security of the nation, increase the security of the state. For renewable energy integration experiences, we have like lots of regulations now, because the grids are not yet ready. The penetration extensive and deregulated. Regarding vehicle integration, we have now limited features. In future, we will have lots of extensive features, including the vehicle to grid concepts and lots of things. We don't have storage options currently now. And even if we have some, it's very difficult to coordinate. Like, where is the energy that is coming to the storage, and when the storage will dispatch the energy. So there are lots of coordination things required, which is not fully, I should say, functional. But in future, it will be coordinatedly, highly coordinated. Currently, we don't have much of demand-side management system practices, but in future, definitely there will be scopes because of the communication channel. It will be easy to interact with the customers. Regarding electricity market, Western countries have already they are practicing these things for a long time. But in countries like Bangladesh and recently developing countries, we don't have much of these practices. So we are still lagging behind regarding the bidding strategies. What could be the list, the marginal price, the maximum of the students. We don't have concept about this energy market, because in day-to-day life we don't use it. So currently we don't have this concept here in Bangladesh, but in future definitely there will be, gradually this concept will be coming. And finally, the whole operation of the power system is based on historical experience, like what happened then, what happened 5 years ago, what happened 10 years ago, okay, what could happen in next couple of days, looking at the forecast, or maybe based on the historical data we try to predict. But when we can implement the fully functional smart grid, it will be totally based on real-time experience. So lots of things will be done behind the scene on real time, and that computational all things will be reflected on the real-time operation of the system. So basically, smart grid is a concept and vision that captures the range of advanced information, sensing, communications, control, and energy technologies. Taken together, these result in an electric power system that can intelligently integrate the actions of all connected users. And here I can see a complex network. So from power generators to electricity consumers to those that both produce and consume electricity to efficiently deliver sustainable, economic, and secure electricity supplies. So here I wanted to show you how the communication network is superimposed on the power network. So we had the power network already built because for a long time we're getting power. Now the change is we have a very robust communication network that has to be superimposed on the power network. So that will basically create a cyber physical system or a cyber physical network. So this will basically enable the benefits from in the form of small power producers. So there will be lots of power producers coming into the market. They will try to gain something from the market. There will be deregulated energy market. There will be lots of options for distributed generation, then multi-directional power flow. And finally, that the most important thing I said for countries like us, active customer participation. Why I am telling this is the most important right now, I'll come into that gradually. Before going into lots of features, just I would like to say the smart grid definition. Theoretically, there are lots of definitions by different entities who are working on it for last many years. So here the definitions are from US Department of Energy, and also there is another from European Technology Platform Smart Grids. So it's already, I have already mentioned all these things, that it's a complex network, and starting from generator to consumer, everyone will be connected through a complex network. Everyone will have interactions with each other, and that will basically deliver a sustainable, economic, and secure electricity supply. That's the main goal actually, to get a reliable, secure electricity supply, which has to be economic as well. And so now, before going to explain furthermore, I wanted to show you the figure here on the left-hand side. This is from one of my papers that I wrote back in 2011. This paper was published in 2000. Yes, I did it in 2011, and the paper was published in 2012. And that paper was, I think, one of the first few papers regarding the smart grid establishment of Bangladesh. And I had some interesting experiences when I was working for my master's thesis that time. I came back to Dhaka to get some data from DPDC, because my research area was based on Dhanmondi substation, which is basically now near Katabon. So I had to look into lots of things so that I can propose a model for smart grid, like what needs to be done for Dhaka, Bangladesh. And interestingly, that was a very, there were only few people who knew what is smart grid. So the research was, started long ago, but due to lots of things, we haven't seen the implementation as so far. So there's a big gap. Why the gap is creating? Because of that customer issues, because of that economical issues, because of that, lots of geopolitical and international political issues, because I have already said that energy and electricity is a very sensitive sector for any government. So every time policy changes, every time things changes. So back into my slides. So here you can see lots of interactions are done among these 7 entities: generation, transmission, distribution, customer. Then we have deregulated market, control and operation, and the management and service. So starting from your home building management, or you starting from billing and maintenance of your devices, till the generation from the renewables and or fossil fuel energy resources, everything is internally connected. So if there is a big problem in one entity, other entities will eventually have effects. It enables demand-side management, as I have already said that demand-side management is one of the crucial things or one of the crucial outcomes of the establishment of smart grid. So what is demand-side management? If a customer asks you like, what's in it for me? I should say money, because when we can use smart things, we definitely make it smart. That means we try to make it economic. So when you know that your electricity rate is changing, you have peak and off-peak hours, you have, sometimes electricity rate is very high, you don't want to consume some electrical appliances, just turn it off. When you want to see that I want to run my washing machine now, I want to run my dishwasher now, these are some, luxury appliances which you can use at night or you can use early in the morning when the electricity rate is lower. So that's how you can, take advantage of the lower rate. So that's only possible when you know what is the rate in real time. At the same time, on the other hand, the grid needs to balance it. The balance what? The generation and the supply. I mean, the generation and the demand. So when you need to balance it, they have to continuously check what is the demand. So when your demand is increasing, every year demand is increasing. So it gets very difficult for the utility to cope up with the increasing demand. So they have to invest lots of money, they have to change the policies and lots of things they have to incorporate into their plan. So what they can do, they can give some incentives to the people to turn off your unnecessary electrical appliances. But we know that Bangladeshis and we people, we are very luxurious by, in lifestyle. Let the light turned on, let the light and fan turned on, doesn't matter at all. So you are losing money then, but the grid is basically profiting from you. And after a few months, then you'll see, oh, I am giving lots of money. So then you will be conscious. So how you will be conscious? The grid will tell you that, okay, now you can do that. You can turn off your unnecessary, electrical appliances, which is consuming this. So that's how you can basically save some money. Because right now we cannot see what is happening immediately. So we get the bill after a month. So then we don't have anything to do because we have already consumed. So the next month we try to become, a little bit economical in our operation, but still depends on your behavior. When we have demand side management, we can be prosumers. Prosumers in a sense that you are producing electricity through your renewable energy generation facilities. Maybe you have solar PV, you have small wind generation, something like that. And when you have excess electricity, after you consume that renewable generation from your premise, you can also sell it. So that's how you can make the money from the grid. So that's how the consumer is engaged, continuously consumer engaged. Without the consumer behavior, without the consumer interactions, without the consumers change in how they want to get the electricity, the smart grid cannot be ever fully functional. Okay. So that's the thing I was continuously saying, that consumer is one of the most crucial, entity in smart grid. Sometimes I say we are no more a consumer now. We have become a customer, because when we say consumer is basically you are continuously consuming. You don't have the right to reproduce that and resell it to anyone else. But when you are in the smart grid platform, you become a customer. You have the chance to become a customer, because as a customer, you can, play a role as a third party. So you get something from the grid and then you can, reproduce that or, somehow change that to sell it to someone else or, disseminate it to someone else. So consumers, the customer's characteristics, it is a bit different than consumers. When the customer plays, enjoys, basically the customer enjoys lots of more functionalities. So personally, I say customer instead of consumers. So now we have lots of ideas about why smart grid is beneficial to the community and how it brings lots of interesting things in our life. Now I'd like to one by one go to the different features of smart grid. Though there are lots of things written in the slide, but trying to keep it simple, I'll just explain very shortly. So the first feature of the smart grid is the smart home and the smart meter. So your smart home means maximum of your electronic devices will talk to each other. Maybe you have seen the movie I, Robot. Will Smith was there. And lots of recent movies are there coming. Even the Iron Man. I sometimes see the movies continuous. Like there are lots of Iron Man, I think part 1, part 2, part 3. So every time I see that movie, even in the Avengers, it makes me amazed, like how these robots talk to each other, how these different devices talk to each other. So within the smart home, your electronic devices will talk to each other. Let's say washing machine says, I don't want to turn on myself from this time to this time, but I want to turn on at night, maybe at 2 o'clock to 4 o'clock. Maybe the dishwasher says, okay, let me turn on at 12 o'clock and keeps me turn on till 2 o'clock at night. So this is how you can program your electronic devices to talk to each other and then perform their daily operations. And at night, you don't have to wake up. So this is how your smart home will complete its functionalities even you are sleeping. So that's a smart home. Now, to make your home smart, you need a meter, because when you are getting electricity from the grid or you want to sell electricity to the grid, there has to be something in between which basically measures how much electricity you are consuming and how much electricity you basically try to sell. So that's the function of the smart meter. So here I wanted to show you, maybe if you can see my cursor, mouse cursor. So I think I'm doing the laser pointer, yes. So if you can see the laser pointer here, this is the display device. So you have your home display device, something like this, looks very, very smart. The screen is smart and you can, tap into lots of buttons and see lots of functionalities, and you can in real time see what's happening, which device is consuming more, which device is not consuming more, and it will be totally Wi-Fi connected or wire connected, whatever you prefer. You have mobile phone apps to use it when you are outside of your home, so you totally make your life smarter. So this is the basic thing you have to do when you try to adopt smart grid for the whole electric network. Next comes the crucial thing, integration of renewable energy. This is a crucial thing, I would say, because the growth of the power sector needs to growth of lots of its entities. So renewable energy is one of the crucial portions of the power sector nowadays, because this creates lots of jobs. This creates lots of extra opportunities for the people. Apart from the technical things, if we talk about non-technical things as well, because the smart grid is a multi-dimensional topic, not only electrical engineers work on it. There are lots of different backgrounds, people coming here, even people coming from business background who has very excellent programming skill. They can also come into the functionalities of smart grid to work with it. Okay, so integration of renewable energy is one of the very crucial entities, because we want to make our grid greener. We want to get rid of fossil fuels. We want security of the national energy supply and all these things. So how smart grid can give you some advantages. Number one, we know that renewable energy resources are very much intermittent. That means time to time it changes its output. Even if you put a let's say 500 watt rated solar PV panel, during the whole day you may not get 500 watt even for a second, because of the irradiation, because of the temperature, because of lots of other things. Maybe you will see 400, 300, 250, even as low as 50. So to balance it, we need to know that what may happen in future. So this is basically called forecasting. So renewable energy forecasting has become very sophisticated and very modern these days. Even we can predict what happens in next 10 seconds. During my PhD, I worked with some people from Germany as a part of my PhD, and there we developed a model, a forecasting model, which could predict for next 30 minutes, and the resolution was per second. So we could tell you within next second to maybe continuously for next 30 minutes what may happen based on the cloud movements, based on the irradiation measurements, what may happen in the PV power plant. So considering that, when you can produce that forecasting output, how could you adopt it into the system? Because your system has to know beforehand that, okay, this has happened. So you need intelligence here, you need control mechanisms here. So only smart grid facility can ensure this, when you have lots of communication things and lots of people and entity interacting with each other. So better forecasting through the widespread instrumentation and advanced computer models. This is the first benefit we get from smart grid when we integrate renewable energies. Next, smart inverters. Smart inverters can be used for grid support, definitely. Just not only inverting AC to DC electricity. or DC to, the other way, that DC to AC electricity, but it actually takes care of lots of things that grid needs, the voltage support, the reactive power support. The inverter can be modeled to do that. Even these days, lots of battery inverters can work, can give the facility of synthetic inertia. You perhaps know about inertia, which is a very crucial thing we need in the power system. So the synthetic inertia can be also provided by the battery inverters as well these days. Then we have a demand response for system balancing. That's what I said before. We need to balance the system. So based on the scenario, the utility can manage it. We need integrated storage systems for smoothing this fluctuation. So when you have a short time fluctuation, you don't need to turn on a new generator for a very short time, because maybe next 30 minutes the cloud will be gone, the weather will be very good. So why do you want to turn on the diesel generator for a small period, or maybe a big generator for a small period of time? This is not economical. So during that period, you can put your batteries into action and do the smoothing, and also real-time system monitoring and management of the system. Smart appliances. Yes, as I already said, that your smart home is made of smart appliances. So I think I have already explained those things, and your smart appliances basically ensure you how much money you can save. Though you have a little bit of investment initially, but when you run the simulation for a long term, let's say for 5 years to 10 years, then you will see that eventually you are gaining. So your smart appliances has to be there. Otherwise, you will not be able to utilize the full benefits of smart meter. Now smart meter. So as I'm continuously talking about smart meter, so what is it? So smart meter is basically a normal meter that shows you how much real power you are consuming in real time, but it has some additional facilities that is provided by the communication channel. So we are continuously saying there are communication channel imposed on power network. So this is how you can work here. So these smart meters have Wi-Fi enabled features, maybe wired features, so it can communicate with other smart meters through the internet, through the communication channel, and get the data from the utility. At the same time, they can throw the data from your end to the utility as well. So the feature basically includes this remotely accessed meter readings. So the utility can read your meter reading instantly. Like whenever he wants to read it, he just needs to log into your smart meter and he can read the data. So when we try to establish a pilot project for smart grid, we need to know the behavior of the customer, because based on the customer behavior, we need to invest on it. We need to make some policies. So smart meter is the first step. You need to establish it into the customer premise, go through the load profile of lots of customers, try to figure out what they want and how do they behave during weekdays, weekends, different seasons, and then you can change your policy and adapt to different policies. So this is how they can do it. Detailed customer energy profile monitoring by yourself. Like you can also see what you are doing. You can have alerts, alarms and lots of things, and the service provider will be notified instantly. Say if you have any problem in your system, you can immediately let them know. Relays the information to central monitoring station. There are lots of smart meters come in action together, they have to dissipate the information. So that's how the smart meter basically works. And finally, I think that this is a crucial thing, the grid operation centers, because your distribution side is already smart. You have smart appliance, smart home, smart meter. So your grid operation center has to be smart as well. So how they use this smart grid features that has already a very good communication system. So this is how I want to explain you with this, I think I should say, with these block diagrams. The independent system operators basically, schedules lots of things regarding tomorrow. So when you know that the load is, let's say 1 megawatt or 2 megawatt tomorrow, the expected load, so you already schedule 1 day ahead that, okay, this will happen tomorrow. So who will be my service providers based on their, generation profile? So that could be a renewable energy plant, or that could be a fossil fuel based plant. So they do some bidding to these grid operators, and grid operators select them, applying some algorithm. So I don't want to go very details into these algorithms. These are very complex things, how energy market actually runs. Then they do the optimization, the software programming, and then they let the bidders know that, okay, I will take this much of energy from you, this much of energy from another one, this much of energy from maybe a third party. And then finally, the next day, it tries to disseminate that amount of energy that they have already did yesterday based on the contract they did. So this is one portion, that is the day ahead scheduling by the grid operation center. But during that specific day, if you have any change in the load profile, which we could not predict before or we could not forecast before, what to do that? You have to manage it immediately, right? So if you cannot run the real-time optimization system and immediately take action, you will face problems with frequency, voltage, and ultimately grid instability, and lots of things may happen. It may lead to a cascading failure of your different sections of the grid, and ultimately lead to a grid blackout if you cannot manage it promptly. So in real time, what we can do, we knew already what happened in the previous day, and now immediately we know that, okay, we have this much of available resources. This is the system condition. So we need maybe a few more generation. So who is next? Yesterday's contract, we look at the yesterday's contract so we can find out who is next. And immediately we contact him, if you are willing to dispatch some energy now, because I need this much of amount of power or energy, something like that. So immediately they say, okay, I want to dispatch this, and they immediately allocate him to dispatch the energy to the customer. On the other side, in the output side of the grid centers, the retailers, they have to know what is happening actually, right? So the retailers basically contact with the operators that, okay, whether we are getting it or not, I need this much of energy for my customer. Can you supply it to me? Because they are the retailers, they are your distribution utilities. So they have to talk to the operation centers, and they know, okay, at this price, they can get the electricity from that operator. I mean, through the operator from some specific generating company. Okay, so this is how basically this real-time and day-ahead scheduling works. And when we have smart grid, we have communication channels continuously working on these things. We can immediately, make a faster algorithm, make a faster decision making, and disseminate the information, disseminate the power to, like, from bidder to the retailer and then to the customer. And there are some mechanisms for pricing. There are some mechanisms like how you make profit. There are lots of game is played in between, and that will take basically few hours to explain. So I don't want to go into that thing, but this is a complicated thing. But here I wanted to explain that we need smart grid operation centers to make things real, so that the operation is efficient and without load shedding. The reliability is ensured. You can easily make a power cut, but that is not what we want. If we want a reliable system 100%, we have to make sure that every watt has to be served. Okay, so that needs real-time management system. Smart substations. Yes, definitely smart substations are required for asset management. You need to know how the assets are working in your substations. Your substation assets has to talk to each other. Like, let's say the transformers, the relays, the circuit breakers, the other control stuffs we put in the power system. They need to talk to each other to increase the safety, reliability, and also we need to know the health of the assets. In countries like Bangladesh, we have lots of different types of assets which are aged, and we don't know how long it will function. And during a crucial time, it suddenly stops working, and then you have a collapse, you have a grid blackout. So that's the thing. We need to know the grid assets health. Okay, so that's how we can monitor everything within a specific asset. Let's say a big transformer. So after a certain period or after a certain time, we know, okay, the temperature is changing, the winding is having this problem, the oil temperature is having this, or there's something going inside the transformer continuously, which can make it a short circuit inside. So we can measure those things. And in the figure, you can see lots of meters are there, and they can talk to each other and finally make a decision. Okay, so this is a complex network. I just wanted to quickly show you that based on our power network in the substation, we have lots of communication stuffs working there. So this is basically creating a new generation smart substation. Okay, so this is an example of a 220 kV substation. Synchro phasors are there. Okay, so synchro phasors basically try to give you a real-time data like what's happening with voltage and current in some specific areas, and then you can have an idea like if there's any fault may occur within the next few hours or within the next 30 minutes, because there are some devices, if you don't know, there are some devices in the network using which we can predict the system is not going good, or we can predict the system is going abnormal. So if we don't take any action right now, it may lead to some catastrophe in future. So this is how we can take action immediately. So synchro phasors basically help us to do that with the help of wide area management system, and also with the help of PMUs, the phasor measurement units. Okay, so here I just included what type of benefit you can get from it, the dynamic monitoring of the whole system, post-event analysis. If any event happens, later on we can do the post-mortem and find out what happened actually. Then we can also know the oscillation, because there are lots of oscillation occurs in the power network due to lots of instable issues. Then if there is any islanding issue, we can also get to know that. So synchro phasors basically are get data, timestamped data. So what happens in every single time, there is a time associated with your data. So you know that, okay, exactly at that second, this has happened for voltage phasor or for current phasor. Okay, so just to give you a quick idea, this is mainly made up of WAMS, the wide area monitoring system, and also made up of the phasor measurement unit. And phasor measurement unit basically estimates the magnitude and phase angle of the electrical phasor quantities. Those are mainly voltage and current. And wide area management system basically works with the PMUs, and also it gets lots of data from different sensors like frequency issues, the calculations of Rokoff, the situations of different circuit breakers and relays as well. Okay, so the applications of PMU is for oscillation detection. This is the same with synchro phasors because they are interrelated. Fault location, fault classification, event analysis, model validation, and situational awareness. So looking into the data from PMU, we can predict if any problem may occur in future. Okay, am I audible so far? I don't hear any sound. Is it okay? Can you hear me?
Yes, sir. Yes, sir.
Yes, sir.
Thank you. So moving to the next portion, that's an electric vehicle, which is a very interesting thing here. If you can see the right side, the Tesla model, this is in Bangladesh. Okay, so this car is in Bangladesh, this P1100D model, and they had issues with registration. So I also put the registration card here I found in the web, and it was basically categorized as a 5,000 cc vehicle and incurred a huge tax. So that's the drawback of our system, that we still are not much aware of these things, and we are still not ready to adopt these electric vehicles. How do you calculate CCs for an electric vehicle? There are no engines. So this is basically plug-in electric vehicles. So you get electricity, you have a battery inside, you just run the vehicle. It's not plug-in hybrid. It's only plug-in electric vehicle. So it's just run by electricity. So this is a lesson learned for Bangladesh. I really hope we can get lots of electric vehicles in future, as now we are, we have an experience of bringing an electric vehicle and see how it works. Electric vehicle does not only work as a vehicle, but it also works as a energy storage. Like when you store electricity into the battery of the electric vehicle and suddenly you need some electric power and your car is already there, already charged. So you can take the charge out of your battery of the car and immediately dispatch it into the grid or into your home. So your electric vehicle can also work as an energy storage. So it depends on your mechanism. You sometimes use it as a storage, you sometimes use it as a vehicle. So that's how that's why there is a concept called vehicle to grid. Okay, so hopefully we will be able to have a look at these features in Bangladesh in near future. Okay, so I think we have lots of slides to cover, so I have to be a little bit faster. It's already 8 o'clock. Renewable energy resource management is a crucial thing because I have continuously said that we have a fluctuation from renewable energy resources. So if we cannot manage it properly, we'll have inefficient system. I don't say that we cannot properly run the power grid, but definitely we will run the power grid using coals and natural gas, but it will not be very much efficient and the penetration level will be limited. So what is a penetration level? Penetration level is how much renewable energy you can feed into the grid without creating any stability issues. So it could be 25%, 30%, which is a very conservative amount, I should say, if it's a big grid. But if you can go up to 70%, 75%, 80%, that's, I should call a very good penetration level. So high shares of renewable, I should say more than 60%. So when you don't have management for these renewable resources, your grid basically put a specific cap that, okay, you can integrate renewable energy resources, but you should not go beyond this. So suppose you are in a small town where 500 people lives and the overall demand is, let's say, around 1 megawatt. So if among these 500 people, let's say 200 or 250 people wants to take rooftop solar PV panels and they want to be, self-sufficient, but the grid is already there. Grid was already, feeding the customers for long ago. Now, if you want to take the renewables, and sometimes you can just, be 100% renewable run, even for some days. So the grid will eventually lose money. I mean, they are there to make a business, but if you do not take them electricity from them, so they cannot make a business. So if they go out, then you will be totally out of grid. Then there will be again problem for the other customers. So considering all these things, you as a customer, you have to be a part of this overall management, because the grid operator will tell you that you cannot integrate more than maybe 25% of the overall capacity of the network, which was 1 megawatt. So maybe more, you cannot exceed over 300 kilowatt. So you have a capacity fixed. And share all these, fluctuations, forecasting. You can immediately curtail the PV. You can immediately curtail the wind. You can support the grid with smart inverters. Then when there is a problem from renewable, immediately you can take action. So that gives you, confidence that, okay, I can now put up more renewables. Then the grid will basically, release you. And also the operator will allow you, okay, now you have lots of things from your side. We can support you. We have storage as well. So you can, increase your penetration, increase your renewable size. That should not be a problem. So the management of the overall thing is very crucial. And here, I just wanted to give some examples that in Durham, in England, they found that just only integrating data and transmitting data in a timely way, that means in real time, the carbon emissions were reduced up to 76%. So you can imagine when you have 76% carbon dioxide emission reduced, that means almost similar amount of renewable you have increased into the grid. Okay. So this is what happens if we cannot manage the high penetration of solar PV systems, and this is what actually happens. I just wanted to give you a quick glimpse what happens. This is the fluctuation of solar PV outcome. So this is a very nice sunny day, and here this is a very cloudy day with scattered movement of clouds and maybe some big clouds continuously staying over your PV panel for a long time. So you have to accommodate these things. Even you stay in Sahara, even you stay in Africa, you stay in a place where the solar radiation is wonderful and the best in the world, you have to keep it in mind that clouds will be there sometimes, and the amount of cloud, you don't know the size of the cloud, that the thickness of the cloud. There are lots of things actually that hampers the irradiation. So you have to definitely keep in mind that there will be fluctuations, definitely, and your system has to accommodate that problem. Okay, so the reliability is the main issue here to keep in mind. I just wanted to give you a quick example here that this data was taken by me when I was working in Germany in Oldenburg back in 2017 and 18. So here you can see 4 different types of solar PV outcome. So on the topmost side, left-hand side, here you can see a cold day snowfall. So the irradiance was very low. So this is a very low. And here on 25th February, the daytime fluctuation. So here the clouds were continuously moving on top of the PV panel. It was a good day. Later on in the evening hours or maybe afternoon hours, there was rainfall and showers. So it eventually went down. Then we have on 18th April. 18th April is a spring, was a spring in Germany, and it was a very good, shiny, sunny day. So you can see here the DNI and the GHI was very, very fantastic. And here you can see again scattering. It was a summer day, and irradiance throughout the day was fluctuating, continuously fluctuating. So if you have a big solar power park or power plant, you have to consider this irradiation fluctuation by smart management. You have to do it. Okay, so if these problems, that the challenges that occurs due to this intermittency, it's widespread. It has a specific time scale, like how long it will create problem, and in what area, like up to what area it will create issues. So here in the diagrams, maybe you can have an understand that if it's a power system wide problem, what are the issues, transmission system efficiency and reduced emissions. But if you have a smaller area, your main problems are basically voltage management, power quality, and it happens within a time span of let's say a few milliseconds to few minutes. That means you have to take some actions within this specific time to manage this problem. Okay, so if you cannot manage it, then it will create your distribution system efficiency, maybe load shed, maybe load curtail, PV curtail, something like that. And here I wanted to show you the time scale and the issues regarding what could be the time scale to address these types of problems. The load following problems, generation dispatch needs more time. It's okay, but you have to respond to the dynamic issues or the power quality issues within a very small period of time, like less than second to few seconds. Okay, so these are the problems when we have snowfall. Here we need to make the customers aware that your PV panel is basically working, but irradiance is not good enough because of the snow or because of the dust. So these are the differences. I wanted to show 3 pictures here to create a difference, because initially in Bangladesh, maximum of the solar home system fails because of the lack of understanding by the customer. You just put a solar panel on your rooftop and you think that it will give you power for next 5 years uninterruptedly, but you don't want to take care of the maintenance because you read somewhere that solar PV panels are maintenance free. This is actually happens because everywhere we read these articles, it says solar PV panels are maintenance free. It takes very small amount of money to maintain whole year. So people don't care, but people are not aware that there are dusts and there are lots of other things falling on the panel. So here you can see the difference. So that's how your solar system may fail. But if you are in distributed, if you are within the smart grid environment and you know that you are availing the demand side management system, you are availing the net metering concept that you can sell electricity to the grid, then you will be definitely very much aware that, okay, I need to clean the solar panel every day because this is how I am making money. So this is how you have to be very much aware. Okay, now moving to next topics very quickly. I think I need 10-15 minutes more. Is that okay? 10-15 minutes?
Yes, sir. That's fine.
Thank you. So there are lots of researches going on how to incorporate all these interesting things from renewables, distributed generations, vehicles, and fluctuations within the system. So you need to have some real-time system management. So when you have lots of data coming from different sensors, now what you have to do, you have to efficiently manage it. So that is basically a crucial work as well. So here I wanted to show you that day ahead planning manager, they will basically try to do a day ahead forecast based on some forecasts and some data from here. fast electricity demand and weather information and those things. And based on this information, they will do the generator scheduling or the unit commitment things, like the which generator will come on the next day, and after which generator will come, and how many units have already committed to dispatch energy the next day. So these things is already done, like a preparation for the next day. Now, when you have issues in the next day that I already explained, like I need real-time system support. So you have to have the data of the previous day and also the real-time data. So here you can see the real-time data of the demand and the weather information, generation and battery support. If you need some storage support, you have to know what is happening at the battery side. What is the storage capacity of the battery and what is the SOC of the battery. So your brain, the control center's brain has to have all information. So you just play around and put it into the right places. So that's how you try to do this real-time operation. And then when you have, let's say, for a small amount of fluctuation, for a short time fluctuation, some of the industries may not tolerate this, because in the IC industries, the semiconductor industries, if you have frequency fluctuations, they will lose millions and billions of dollars within a second, because when they are producing these ICs, they are very much sensitive to this voltage and frequency fluctuation. So they need the most reliable power supply. So if you have any issues, immediately you have to take action. Okay, so if you need more generation or you need to take out more generation, immediately you take action and re-optimize the system. And again, you do the revised generator scheduling. And then you have to also talk with your customers as well to manage it, because at the same time you are running the demand side management. You cannot forget that. You are trying to manage your generation system, and at the same time you have to manage your customers as well. That, okay, I cannot manage my generation, so let's manage the customer. You talk to the customer and say, please, I give you 10 taka, turn off your TV. I give you 15 taka, please turn off your washing machines and all those things. Or I will give you 100 taka in the next hour if you turn off everything of your home. So you have to, calculate all these things, run mathematical models and everything. To every second you have to balance this generation and supply. And otherwise, your fully functional smart grid will be like a thing. Or on the other hand, I can say your fully functional smart grid will enable these things. So it will be very much efficient. So basically your smart building, you have to have a smart building with the function of your smart home, smart cars, smart appliances, everything. Then you make a smart neighborhood. So that's a smart campus, I could say, like all the buildings are here smarter. Then all these areas are combined to create a city. So then you have all smart neighborhoods connected together to make a smart city. And eventually, if you can make one city and at the same time other cities is smarter and they connected through the network, so ultimately you are into the fully functional smart grid. So Professor Saifur Rahman used to say it, smart grid ecosystem. He's a very distinguished professor around the world. He was the elected president of IEEE. So I had an opportunity to talk with him and meet him personally at a conference. And since then, I have been a fan of smart grid and trying to do these things in smart grid. So he has been a pioneer in these smart grid things. So now quickly going into the Bangladesh scenarios. So now we have understood what happened in Bangladesh, what happened in the theory and lots of things, this thing, what should happen. Like now I know what is the ideal scenario. Then it comes your localized effect. Then you have to apply these scenarios and the lessons learned into your locality to get the benefit out of it. So here I just wanted to quickly show you these of generators, which are basically supplying electricity to us. PGCB is the transmission network owner, so basically plays monopoly, and different types of distribution companies, DESCO, DPDC are doing here in Dhaka, and our nearby west sides and north sides are covered by these I think West Power Distribution Company, Northeast Power Distribution Company. Then we have Rural Electrification Board, and also PDB has some distribution facility. So this is basically the overall structure here, and the BERC is there, the regulatory body, and above all this generation, transmission, distribution, the admin stuffs that we need to do are basically done by the ministry and the power cell. So we have the latest power system master plan that was, I think, uploaded in the web and open to public and based in 2016. And we had the vision of 2041. So there are lots of strategies and policies there. And according to their policies, we are planning to increase our generation capacity by 24,000 megawatt by 2021. So we are almost there. I think we have now more than 22,000. So I guess we still have 8 more months to go and catch 24,000. By 2030, 40,000, and 2041, 60,000 megawatt. So this is basically the prediction in future, but we don't know what may happen in the distribution side, because we are the customers. We basically dictate how much we consume. So though we have 24,000 megawatt in 2021, our, I think, peak demand was around 12,000 something or 13,000 megawatt something. So around 8,000 to 9,000 megawatt hour was not used for last couple of years. So what are the drivers for Bangladesh smart grid? Before going to this, I just quickly want to tell you that our system is still inefficient. We have lots of lackings still. We don't have customer participation as well. And our electricity market is kind of, in some portions, it's monopolistic. In some portions, it is oligopolistic. So we don't have a perfect energy market. It's not totally transparent. So there are lots of things behind that has been controlled by the Regulatory Commission. So keeping all these things in mind, the drivers are basically, we need to increase the system reliability and efficiency. We need to reduce the system losses. We need to, think about rapid restoration of the systems, because within last 10, 15 years, we had a couple of times national grid failure because of maybe a small frequency disturbance in a small network, in a small portion of the networks, and because of the aged infrastructure, it actually created cascaded failure in all our nearby generators and ultimately failed the whole grid. Like what happened, I think it was in 2017 or 18, the HVDC station that we have with India, they had some issues with generation and eventually frequency collapsed in our side, and that led to lots of complex scenarios, and ultimately our grid failed. So we need a rapid restoration of the system, and this will basically ensure when we have problem in a certain area, it can isolate that area, so the rest of the area can function properly. And also these things we have already discussed, the asset management, grid feasibility, consumer interactions, and all these things. So consumers will be benefited by fully expanding the access, because when you are trying to integrate lots of renewables, you can include solar home systems, solar mini grids, microgrids, lots of things are happening around the country now. So almost 100% electricity we are aiming by this year or maybe early next year. And this will basically create a situation when we don't have any power cut, no load shedding. It will create a stable power system for us. And if we have, distributed, DSM, the demand side management fully enabled, so then we can, get some revenue, and ultimately doing that, we can save some money, and as well, eventually, I should say, if we are careful enough, maybe after 1 year, like every month, we don't need to pay the bill. The grid will give you a check of some amount of money, because you have been very good prosumer and you have sold lots of electricity to the grid, more than you consume. So ultimately, grid will, at the end of the month, the grid will pay you the money. Okay, so what are the benefits for government regulators, or the drivers basically? The reduction of carbon dioxide emission, because we have to reduce it. We are a treaty country of Kyoto Protocol, and also we have been a key country fighting the climate change. So we have to be very careful about our own carbon dioxide emission. And then we have fuel diversity issue that also linked to the energy security of the country. Customer satisfaction definitely, and of course a modern Bangladesh. Finally, if I want to set drivers. There was a paper published in 2020. There was luckily I was the reviewer of that paper, and that's basically the title of the paper was Adaptation. It's given here in the reference, Adaptation for Sustainable Implementation of Smart Grid in Developing Countries like Bangladesh. So here the authors basically proposed lots of interesting things. So they identified the problems of Bangladesh system currently. what is happening, and these are highlighted here. I think you can, we have already talked about these things. We have lots of problems with, including power theft, unwanted blackouts, grid failure, inefficient issues. And then they model something. So I wanted to show you how they model it. So for smart grid adaptation in Bangladesh, the first thing we have to do is implementation of the smart meter, rollout of the smart meter throughout the area. So pick a utility, that utility should specifically choose some specific area, roll out the smart meters there, try to see what happens with the load, track the load behavior, track the customer interactions. If the customers are satisfied, then you expand your pilot project to another nearby area, and then try to continuously synchronize these areas together to make a huge areas under the smart grid. Then we basically try to build upon that. So that's how it will work. So finally, when we have smart meter, then we can also do this net metering concept, which will help to upgrade the distributed generations. We can include the distribution automation, all these things. We can integrate more renewables. So we have now bidirectional communication, and ultimately, when these things we can ensure, we can also consider about incorporating an energy storage, because without energy storage, we may not get lots of facilities that can be offered by smart grid. So they did a small cost analysis, which basically was based on Polli Bidyut Shomiti section in Dhaka and also nearby Dhaka in Kaliakoir, Gazipur. And they have like around 185,000 customers. And they estimated that whole cost of turn system to smart grid, it will cost around 1,060 crore Bangladeshi taka. So it's a lot of amount. Only a small area of 185,000 people will cost 160 crore. Very challenging. We have already started metering. So the people who don't know about the recent updates, I just want to give you quick updates what's happening now in smart grid establishment in Bangladesh. The recent updates. We have already started deploying the smart card metering systems. So basically, those are nothing but prepaid meterings. So you already know how prepaid works. You just put some money, and at the end of the day. Sorry, why? Okay, can you see the screen again?
Not yet, sir.
It's all right.
Not yet, sir.
Not yet. Okay, let me check why it just. Is it okay now?
Yes, sir.
So we can see the notes.
Oh, you are seeing the notes?
Yeah.
Okay, so let me change the. Is it fine now? Or it's, I don't know what's happening. Suddenly stopped sharing and everything.
So we still see the notes.
Okay. Let me, suddenly what happened? Just give me a couple of seconds. Now, the notes.
It's okay now.
It's okay, or the notes?
Sir, the notes are.
Okay. So let me just change it. Okay, now I think it should be fine now. Is it okay? Okay, great. So, so these are simple prepaid meters. But if we want to include smart metering, this interesting infrastructure based on communication channels and all these things and all those different facilities, we have to put lots of interesting features into that prepaid meter. Otherwise, we cannot claim it as a smart meter. And that smart meter has to talk with you. It has to take inputs from the customer, and also it has to give some something to the utility at the same time. And through that smart meter, utility has to let you know some information. Otherwise, this prepaid meter cannot be told as a smart meter. But it's good that we have already started doing something. But the question is, if we start rolling out the smart meter, who is to pay for that? Who is going to pay for this huge amount of money? Because each of the smart meter will be very costly. So let's say if I am willing, my neighbor is not willing, then it will be very difficult to synchronize, right? So the policy has to be there, how to manage these things. So considering all these problems and issues, the first initiative has come from Dhaka Power Distribution Company, DPDC. So they have already planned and they have made some, contracts with some foreign companies. They have managed some aids from some European companies and European Union to create a smart grid, smart grid facility within its utility for some specific areas. So here are some of the newspaper links I wanted to show you that DPDC has already started, and these news were back from 2018 and 19. So I really hope DPDC is doing something right now. Though I am a DPDC customer and I'm still using the old meter and I have to pay every month manually. So I don't know how they will eventually achieve the target, but hoping for the best. So this is what I found in their in the web, that they are targeting around 1 million people. More than 1 million people will be significantly have the good vibe from this smart metering system, which will reduce huge amount of carbon dioxide emission. And they're targeting by December 2022 to finish the pilot project of the smart grid. So lots of crores of taka, you can see here, 381 crores of taka from the government, then 1056 from the project aid, and DPDC will spend 88 lakhs from its own fund. The French agency has come forward to work on it with 942 crore taka, European Union around 103 crore taka. So it's around the 1,500 crore project. It's a huge amount of money. And the substations they have targeted mainly concerning Jigatala, Lalmatia, Asad Gate, Satmurjid Road, and I think Green Road. Yeah, this area. So people who are living in this area, be optimistic. Let's see what happens in 2022. So the challenges I personally feel for Dhaka, though as a utility, they issue lots of challenges. They say lots of challenges, but as a customer, not as a expert, not as a critic, as a simple customer, I see there are lots of issues. Number one, we have sharp increase in the demand of electricity because the area they have picked, it's a densely populated area, so continuously population is increasing. Secondly, if we roll out lots of smart meters, let's say even before the customer are much aware, and if these smart meters are hacked, so who is to be responsible for? So these things has to be very clear. And if these things are hacked, the hacker will basically gain access to lots of things. Even they can also control your home from just outside. So when you are establishing a communication system, it has to be very stable. So you have to have that confidence. The customers have to have that confidence. Okay. That's why I have written here customer awareness and attitude towards the demand side management also, and definitely demand side management means smart meter. So if you as a customer, if you are not much aware and confident, it will be difficult. And also there could be issues of threats for cyber physical system, like when you have a communication system, through communication system you can attack your substation, you can attack your transformer, you can attack your circuit breakers to unnecessarily trip some feeders. So without knowing, suddenly something will be tripped. So we have to be very careful when we roll out these things. And social acceptability, because we people from Bangladesh are very different when we try to adopt new things. So we have to be very, very careful about these things. So I think there are lots of things to say. Anyways, quickly showing the rest of the slides. So regarding distributed generation readiness, Bangladesh has already lots of distributed generation facilities are there. I think you people all are aware of that. We have Kaptai hydropower station, lots of small independent power producers are there connected as the distributed generators. We have some solar and wind farms now connected, and lots of new farms are already coming into the action. We have lots of solar home systems across the whole country, and regarding solar home system, we are pioneer in the world. This has been a very interesting model which has been followed by lots of countries for last 5 to 10 years. But now solar home system uptake has been a little bit reduced because the maximum of the country has now been almost electrified. So the uptake has been reduced in the remote rural areas. And we have lots of industries trying to produce their own power around 3,500 megawatt. So these combinedly, all these things, we call it distributed generation. So we have there, we're already there. Regarding the integration of renewable energy resources, SREDA is there, the Sustainable and Renewable Energy Development Authority. They're basically taking care of all these renewable energy projects and trying to find out who is producing and who is not producing, and try to adopt the policies, create new policies, and suggest the government about these things. So they have targeted around, let's say, 15% of the total production should come from the renewable in 2021, and in 2030 it should be around 20%. So that's the strategic planning by SREDA. So these are the potentials we have. If I just want to quickly show you, we have very good solar potential here in Bangladesh. So even if we don't have much penetration now, but we can suddenly take some initiatives to increase the penetration. Wind mapping is already there. We have already done the wind mapping through NREL, United States. So that's a famous renewable energy lab. And the entities involved developing this sector are the public-private partnerships and also the public sector. Then we have hydro, very limited, but we can also harness that, starting mini hydro projects, micro hydro projects in hill tracts areas. And there are lots of biogas and biomass things we can always do in the village and rural areas. So currently, I just wanted to show you the data. We have around 22,288 megawatt of generation capacity in the country. So that the data is very latest, yesterday's data. And from there, we have around 722.6 megawatt coming from the overall renewable, and the maximum shares coming from the solar. And then solar includes all these things: your rooftop solar, solar park, net metering, irrigation, mini grid, microgrid, solar home systems, charging, whatever it is regarding solar, everything is accumulated here for 4,488 megawatt. And for net metering that I was telling, net metering means you have a solar PV panel for your own, and after consuming, you want to sell to the electricity. So we have such systems. Those are already online working, around 1,271 pieces. Okay, so 1,271 pieces, which has capacity of around 23 megawatt. So 23 megawatt of power that can be harnessed from the different customers, which are supported by these different utilities. Okay, so the topmost one is from Korean EPZ in Chittagong. I think they have around 5.25 megawatt peak rooftop solar system. So that's a big amount, 5.5 megawatt. Okay, so to make all these things functional, we need a bidirectional communication channel, and there hasn't been much progress regarding this. So we need to create the home area networks. Every smart systems need smart homes. So your smart home can be within the home area network that we call the network is known as home area network. Everything within your network is the home area network. Then all these smart homes are coming together under one neighborhood. So that's basically, we call it neighborhood area network, something like that, NAN. And all these neighborhoods are then connected with a big network that is the wide area network, WAN. So WAN has the components of lots of NANs and also the distributed power resources and the control centers, different types of power stations and all those things. Basically, the wide area network is the core of the whole communication system, and everything that you can control or you want to control can be controlled using this network. Okay. So this is already, we have here in Bangladesh, the optical fiber backbone network covered by the BPDB, Power Development Board, and IPP owned power stations. So these grid substations are already connected to each other. So we have been advanced, a little bit advanced, definitely. We have a satellite now that was thrown in 2018. So we are getting lots of data from there. We have last mile fiber connectivity or solution by BTRC and lots of other third parties. We have mobile phone operators having wireless connectivity throughout the country. So these are really good things that we have communication channels working throughout the country, but we need to coordinate everything. So that's the thing we are missing. And we have a very good system of online or mobile bill payment facility, which is not even there in many Western countries as well. So this is a very good thing. Like we can pay through bKash, Nogod, We can pay using cash and using credit cards, lots of things, like whatever you mention it, we can use that to pay the bill. So this is a really good thing, that these utilities are basically connected to each other, like the banks and these utilities, the profit makers and the policy makers and all this, they are basically connected to each other. So these things, these are really good. Regarding energy storage devices, we don't have it yet, but for smart grid fully functional, we need to think about centralized energy system once based on the lithium ion maybe, or redox batteries or something like that. There are lots of different new technologies coming, but lithium ion technologies prices are going down, so we can consider lithium ion batteries nowadays. And they can be used for two things. Number one is the grid stability. So if there is any problem with the grid stability, it can immediately take action. And secondly, if the price changes, that extra energy can be sold to the grid to make some money, because the battery system or the energy system will be a differently independent operator. So he has to earn some money by selling the energy that is from the battery. Okay, so some mechanism has to be there. Demand side management, we haven't started yet, but we have started energy efficiency and conservation awareness program. Lots of international NGOs and organizations are already working with it. Government is also working with it. We get lots of emails and SMSs and also lots of ads through television that please be aware of your energy use and those things. Do not turn on the lights and fans unnecessarily. And these are really good that people are getting accustomed with these initiatives gradually. But I don't know what will happen to the general people who does not have or who are not much aware of these advertisements from the governments or SMSs or something like that. So this will definitely take time in a country like Bangladesh. Distribution intelligence, definitely there are certain level of distribution intelligences. I think I should not. It's very difficult to make some comments on it because it's a very core portion of a power network. So definitely they have distribution automation, but it's limited, I should say, up to that. So we can basically, increase the automation functionalities. We can increase the computational models efficiencies, the softwares and the tools. We can, all the researchers, we are continuously working to improve the, algorithms, the computational time that is required to solve an optimization, non-linear optimization. It takes a long time. So the more you saving in time basically can be very much useful for real-time implementations. So these are the things we have always wanted to implement in the system. And application of GIS is one interesting thing, geographical information system. So based on GIS, you have lots of layers in a software tool that you can see, okay, what is happening in each of the layers. Let's say for a specific substation area, you are creating a GIS model. So in one layer, you're putting the electrical equipment's data, one layer you are putting the load data, or one layer you are putting the customer's data of that substation and something like that. So if you do that for the whole network, so every layer you have different information for different things. So ultimately it will be very easy for you to manage it and run some, optimization modelings. So that will basically help you to find automated route selection. So let's say if you have a problem in a specific line, you wanted to switch to another line, or you wanted to turn off that line to put that customer into another line. So which would be the most economical solution? So that can also be done when you see the geographic information system, the interface, because you know the GPS location, the latitude, longitude specifically of that specific asset. So then if you have any problem with some assets, also you know that exactly on which location you have the problem. So you just immediately send the people to specific location. So that's how we can do the asset management and maintenance issues as well. And also proper land using. When you search renewable energy planning, you will find lots of research papers based on GIS. So those are basically try to find out the suitable land for expansion of the grid, or integration of or putting new solar panels based on the irradiance and all those things. So GIS is a very crucial, interesting thing. It was not there before in Bangladesh, but recently they have adopted it and they are trying to use it to the full capacity. Finally, I'm just only a few slides away. I'll just quickly wrap it up here. regarding some policies that we have now. We have some energy import issues with India, because this is a part of smart grid as well, because we don't have to only rely on what we have, and as such we don't have much renewable penetration now. We have only 3% to 3.2% of renewable penetration in the country. So for security, we have to have some bilateral communication with the neighboring countries, and the most feasible option was India. So we had power import export, not basically export. We import power from India through one channel, and I think they're building another channel now, if I'm not wrong. So currently we have around 750 renewable capacity. That's I wanted to mention, and it is still a very small amount, because according to the SDG 7 goal, which is basically Sustainable Development Goals set by United Nations, we should have around 12% by now. So we are lagging behind. So we have to be we have to run fast here to catch this value. The potential is there. There has been a roadmap already published, available in public, the solar energy roadmap from 2021 to 2041. That was written by Shahriar Bhai from UIU, and he has planned that around 20,000 to 30,000 megawatt can be generated if we, correctly coordinate all the solar PV panels, including everything, solar park to solar home systems and everything. Definitely, we have land issues, but we have to be very, carefully choose the lands when we want to introduce renewable energy systems. We can choose lots of nearby areas and the islands of Noakhali, Chattogram, Bhola and Borishal. We have to have a political will to introduce lots of wind energy power plants, because I personally find we have a very good potential, but I really don't know why we haven't harnessed much from the wind power plants. And those power plants which has already been built in Feni and in Kutubdia, I think those are already old. And so far, what I learned from experts, talking with the experts, these projects are basically faulty. So everything has to be very much transparent, and we have to have political will. Ultimately, I wanted to say that the political will and the interest has to be there for wind power. Otherwise, we cannot go for it. Then definitely energy storage. Rohima Afroj, local company, like there are lots of local companies. I'm just mentioning Rohima Afroj. I know about it. So they are producing lots of storage options now. The batteries, different kinds of batteries. So they can be given incentives to create batteries for centralized systems and something like that. And that centralized system could work for grid stability or some energy storage that we need during emergency supply, something like that. And maybe you have heard about the Tesla battery that was being rolled out in South Australia in 2018, when Elon Musk actually openly declared that within 100 days, I will supply a 100 megawatt battery. Otherwise, it will be free. So he eventually supplied that battery within 98 days. And before even 100 days, the battery was functioning. And within less than a second, the battery picked up the peak power. So immediately, you need the battery support. Immediately, less than a second, the battery took the command and dispatched its energy. So that's how lithium-ion energy battery works. So I usually call it fast response batteries, and I did some works during my PhD with these fast response batteries. These are a little bit expensive, still expensive, but for a long term we can consider, because the price is gradually coming down. And we can introduce lots of DC equipments now. I think in the market there are lots of DC equipments because the solar batteries and winds, they can generate DC power. So we don't need inverters. Directly we can use the DC powers in places where we can use. Here I wanted to talk about some import of hydropower that we have been talking with India recently, because to go for smart grid, I have been continuously telling that renewable energy penetration, high penetration is mandatory. So why not importing power from India or Nepal or maybe Myanmar? I think they were also planning to import hydropower from Thailand through Myanmar. So it's going to be a big network. And interestingly, hydropower is basically not pollution free. This is one of the crucial, I guess lots of people do not know about it. The hydropower is one of the very crucial emitters of methane gas. So if you can see here, Dr. Philip from National Institute of Research in Brazil, and he's one of the most cited scientists regarding climate change. He said it's a methane factory. So your hydropower plants are basically methane factories. And how it emits methane? Through this organic material, vegetation, sediment, and soil that flows from rivers into the reservoirs and decomposes. That's how it emits methane. So maximum of the cases, we just disseminate the news that it's pollution free and it's just the water that is rotating the turbine. But behind the scene, there are lots of things. So when we talk about importing hydroelectricity from India, we are basically trying to encourage that pollution. We also try to encourage issues with the geopolitical issues among China, India, and Bangladesh. Maybe you have heard recently, China is planning to build a big dam on the river Buriganga. I think they have that Yarlung River, Yarlung Sangpo River in China, which basically comes to Bangladesh as Brahmaputra, not Buriganga, the Brahmaputra, and then it goes to the Bay of Bengal. So we have to be very much, careful about making such decisions, because these things actually create lots of issues. And when we try to import that electricity from Arunachal, from India, they basically try to build the dam for us. And eventually this will create water scarcity, the drinking water scarcity in summer season in Bangladesh. And we have to give lots of land for that as well, for the transmission network and distribution network. So with the limited capacity that we have to be very crucial regarding these choices we make. So rather doing these things, I would suggest go for, creating partnerships regarding the renewables. See, in India, in Gujarat, last couple of years, they have been doing amazing, good jobs regarding renewable energy projects. The whole state could be 100% renewable energy supported maybe within a few years. China is doing really good. We already know that maximum of the electrical equipments regarding solar power is coming from China. So why not creating a bilateral contract or something like that with these countries regarding renewable energy network? So this is one thing where we can work. We can also work with the microgrids in creating microgrids and force the universities to create microgrids for themselves. The engineering universities in Bangladesh, we have been there for like lots of years now, and we should have been self-sufficient using our own resources if it's feasible. Definitely, I should say, if it's feasible. We definitely run a techno-economic analysis, and if it's feasible for the university, then I think they should go for it. Because demonstration purpose, there are lots of microgrids there in lots of universities in the Western countries, and students are basically conducting their research over there. We can also look into hydrogen energy resources. These are recent things. Some of my students are working with hydrogen energy, and they have found a little bit, it's reasonable. It's still reasonable. We can introduce it in Bangladesh system as an energy storage. And we can also impose carbon tax to the emitters who are emitting some fossil fuel generators, because we now already have lots of spare capacity of generations. So we have to be very careful when choosing the generators which are basically going to electrify us. So my last slide will be about proposing a public and private partnership investment, because we in Bangladesh, when we talk about successfully completing something, you have to involve the customer, you have to involve the people. If you take the money from the people will be very much aware that, okay, I have given some money or I have invested, so I have to be very careful now regarding my behavior, regarding my something. So just do not incentivize something, just don't go to get some aid. Better you go for public-private partnership, then it will be very much helpful for everyone, because we want to take part with this in this revolution of Bangladesh power sector. So this is one of my observation, and thanks to these authors from Green University who have basically came up with a very fantastic sentence. In the last sentence, you can see the most important parts of this fund management has to be maintaining transparency, because smart grid is a multi-billion-dollar project. When you start doing these things, it will involve billions of dollars. So if this is not transparent, your money will be wasted. Your public interest will not be served. So it has to be made sure that we make the use of money perfectly. We have lots of limitations. We have to take care of these limitations. Definitely, those things are not prepared. I think I have covered these things in every contents. automations and grid codes, central generation. We have the growth is slow for renewable energy sector. The customers have poor affordability. We don't have dynamic tariff structure. SCADA is not even modernized. So these things are almost, I think, common for maximum of the developing countries. So finally, this is what smart grid means for Bangladesh. We have very good solution there in front of the people, very good, very smart and amazing solution there in front of the government. The world, there are lots of pilot projects which has been successful and they have already, they're already a part of the smart grid. So even 10 years back when I was doing my master's, it was a concept. Now I see after 10 years when I'm presenting in front of you today, I am seeing that lots of things have already been started implementing and lots of islands, lots of small areas have already enjoying the full functional smart grid. So we can take the lessons from them and learn from them and eventually, make our electricity grid, Bangladesh public power network, a greener one and a very beautiful one and a very fruitful one. So thank you very much. And I apologize for a long presentation.
Sir, we can have
Thank you, sir, for this descriptive but very insightful presentation. You covered a lot of topics, including the policies regarding smart grid and from all aspects, I guess, the technical, the business aspects. So it was a very informative session. I hope all the participants did enjoy your lecture and presentation. At this point of this presentation, I would like to call upon the participants. If you have any question, the floor is open for you. Dr. Taskin will answer your questions. If you have any queries, please, you can unmute yourself and ask your questions.
Yes, please feel free to ask lots of questions. Could be informative questions, could be something I can learn from you, could be silly questions. That's also fine.
Sir, this is Arnav. Hello.
Hello. Yep.
Yeah, this is Arnav, sir.
Arnav, hi. How are you doing?
Yeah, I'm fine. Thank you, sir, for the long presentation. For the last 2 years, I'm residing in Shirazganj. Okay, so here there is a renewable energy source which is wind-based power plant, wind turbine-based power plant. But I am seeing that most of the times don't operate because of the lack of wind. So my question that we create new renewable source energy like windmill power plants, but there is a lack of wind, so they cannot operate through the whole day. I cannot say the whole year, but the whole day they don't run because of lack of proper wind. So how can we implement this kind of such power plants like wind energy in Bangladesh, and is there what is the feasibility of that we make those power plants for the renewable energy for sustainability, but they don't operate because of lack of wind? I think you got my
I perfectly got your question. Thank you, Arnav. For audience, I can tell you, Arnav was one of my very first students. I think 10 years ago, Arnav, I used to maybe almost 10 years ago when I was teaching in University of Asia Pacific. He was my direct student, and now he is working as an engineer with some power stations, I think. So regarding wind energy, the thing is, see, when we implement a project, there are few things we do. Not only technical analysis, techno-economic analysis, some feasibility analysis. So that's what I was mentioning in one of my slides, that we have to have a very transparent system. We have to have good political will to introduce something. Let's say you just from outside and you just put it somewhere thinking that, okay, I have some air is flowing, maybe my turbine will rotate and I get some electricity. Eventually you don't, if you don't study what is happening behind, like your air speed, your air dynamics, which direction the air is coming from, and which turbine basically you are using. If these things do not synchronize all together, this will be totally a waste of money. If we look at the wind energy map that has been prepared by Renewable Energy Laboratory for Bangladesh, specifically for Bangladesh, a couple of years ago, which actually created lots of controversy, because we people were not ready to accept that we really have very good wind potential. And then when NREL came up and said that, see guys, you have 20,000 megawatt renewable energy potential just only from wind, people were astonished, including lots of researchers. So in that map, we found that the airspeed was very good in the offshore areas, in the southern side of Bangladesh, not only in Cox's Bazar, Chittagong, but also the southern portion of Sundarbans. So I would suggest to go for wind turbines, the big size wind turbines, to that offshore areas. In onshore, we have to check the that air dynamics. This is a very crucial thing for wind turbine. For that, what kind of turbine we're choosing, whether it's a horizontal axis turbine or it's a vertical axis turbine. So different turbines have different strategy to create electricity. So I'm not sure about that project, like what was the speed and something, but these things have to synchronize all together. Otherwise, yeah, that what you said, it's not fully functional. I think those are the cases. Maybe they didn't do good homework.
Okay, sir. Thank you. Thank you for your answer. Thank you, sir.
Thank you.
Assalamu alaikum, sir. Am I audible?
Yes, perfect.
So thank you, sir, for your wonderful presentation, sir. I was thinking like that, as you said from your presentation, that where our renewable energy production is not that much. Our renewable energy production is only 3.24%, for which isn't, I think, is not a good deal for going for smart grid. And in power sector, there is three parts: the generation part, and the transmission part, and the distribution part. So, sir, as you said from your presentation, that we have 20,000 megawatt production in our nowadays in Bangladesh, but our demand may be 12,000 or 13,000 megawatt. So we have 7,000 or 8,000 surplus electricity production. So where is still going for more production, like we are going for nuclear power plant in Rupur. Maybe there is another plan. There will be 2,400 megawatt. But in our the two other parts, generation parts and distribution parts, maybe our distribution parts isn't good. It's so poor. So we are facing load shedding frequently. So in Bangladesh, is the political will a major barrier for implementing the smart grid? As we have the solar potential and wind potential and many other, we have the Bay of Bengal in the southern part. We can install offshore wind park, so or solar park. Maybe the government isn't trying that thing not much. So is it a barrier? And what would you do if you are a policymaker's position at that part? Thank you, sir.
Okay, thank you very much. That was a really nice question, and a crucial question, I should say, as it is related to government. Okay, to answer your query, number one, see, power sector is one of the money makers. Okay, so it's a money maker for any public entity, any private entity. When I was in, when I finished my master's in Thailand, I did it with power system management and all these things. I tried to get into the local utility company because my supervisor was an advisor of that company. And eventually he could not help me because Thailand, on being a country, they need people who can speak Thai and also Thai national. So that means you are being a power engineer, when you want to work within the power sector, you have to be your own product. So why is that? So that gives an idea that, okay, something is fishy. Okay, so everyone, we know that in every country, power sector not only depends on technical things. There are lots of internal issues, lots of political issues we went to Russia for nuclear power plant. Why not in France? Why not we went to America? So it's just not only technology. There are lots of things we're playing behind. We know it. So regarding renewable energies, I should not give my personal comment. Rather, I should convey the comments from various experts who are basically much more senior than me. In their different presentations, they actually conveyed that, yes, we have lots of wind energy potential. We are not harnessing it because there is a good money in solar. Solar panels are very, very easily to set up. Solar equipments are very easily to bring from China or from other countries. And it's a good business here. People understand it very easily. And for wind, yeah, that's the first question was from Arnob. So I explained that there are lots of issues to learn from wind. So it is much more, I think, a little bit more complicated than solar. So we chose the easiest option. Number two, when you talk about this export import stuffs regarding your energy things, lots of monies are there, and based on your policy, you can actually dictate, okay, now I need a quick rental for next 2 years. So who is going to be the owner of the quick rental? It's totally dictated by you. It's not an open market. I cannot bid. Even if I bid, maybe I will not be selected. So these are some things are there. And even now we have very high power generation installed capacities around 22,000. Like that means I am ready to support 22,000 megawatt. This is what I personally feel. Or let's say to 20,000 megawatt. Okay, if I need, I can give you 20,000 megawatt. But our maximum peak maybe, let's say roughly 12,000 megawatt. So this 8,000 megawatt, there are errors in planning. They estimated that the demand growth will be very much steady, but eventually due to, let's say, Corona or industrial effect or international issues or economic recession or whatever, the demand was not that much. At the same time, we introduces energy efficiency measures, energy conservation measures. So there were some miscalculations, I should say. And now we are basically paying the price, because that extra generators which are basically not running has to be paid, and we are paying them just for sitting idle. And how we are paying that? Because that specific portion is coming into our tariffs. Okay, so that's why the tariff has been increasing for last 2 to 3 years. So to sum up your query, I should say there are lots of complexities actually are there behind that specific decision. So I shouldn't directly say that government is not willing, but yes, there has to be transparent will. If you are will, you show that you are active. If you just tell that we have a will, but if you're not doing it, it creates controversy. So I think that's a diplomatic answer, I should say.
Sir, we have a few more questions. I guess I will read that out to you.
Mm-hmm.
We have a question that said that for smart grid technologies, from which resources can we know about the research opportunities out there, and how much possibility they hold to upscale this particular sector? So he asked about the research opportunities, where to find the resources for these research opportunities for smart grid technologies.
So smart grid, as you have, I think, understood, it's a big thing. It's a big concept. So you have to be very specific on which thing you want to work. If you want to concentrate on power stuffs, you look into the power infrastructure. If you want to, if you have a background of communication or you want to work with communication things, you have to go for communication things. So let's say you want to work on power infrastructure and something like that because you have a power background. So now coming into power background, on which thing you want to work on? Renewable energy integration, policy development, or you want to work on this energy market concept, deregulation. Then there could be different types of tariff structures like economics, energy economics. So even within a power infrastructure or within the energy entity, there are lots of different things: energy planning, energy economics, energy technical things. So let's say if you choose the energy technical thing, then you come inside energy technical and see what has been done very recently. So if there's lots of works have already been done regarding optimization, there have been lots of work done regarding the integration and the stability of the grid. So if you want to introduce something new, maybe you can look for new digital technologies. Let's say blockchain, let's say IoT, let's say peer-to-peer energy trading, these things. So when you very much narrow down your your interest, then you keep searching that how it actually works to make the system efficient, make the system more customer oriented, make the system more reliable, or make the system helps to support the grid operators to run the system smoothly. So eventually that will basically help you to create something for the smart grid. One single person cannot eventually create a whole smart grid, or cannot actually work with the whole smart grid. It will be very difficult part. So I guess, was that the question? Answer to the question.
Yes, sir. Rightly you said. Is there any more questions we have? Do we have any more questions?
Sir, I'm Trina, a third-year student of IUT. As I know, most renewable and resources are not constant. Isn't it an obstacle facing by smart grid, and how to overcome this?
Yes, definitely. That's a big obstacle. I think I showed this photo. Let me scroll here. I can see this is what I showed here. The output is not constant. Let's say for an example, solar PV panel, the irradiation is continuously changing. So you have to know what is happening. So number one, you need to forecast. You need a real-time forecast. So it's already there in the market. Lots of people are doing forecasting. So it's already there in the market. You have to just pick the perfect forecasting mechanism for you and integrate with the system. So when you integrate with the system, you take the data of forecasting data and put it in your optimization software tool, or as a parameter for your modeling, energy modeling that you are going to do. So then based on that forecast, you are running a new optimization, and there you are basically accommodating the generation scheduling, unit commitment, and everything. So where is that coming from? The generators are ready or not? Your other renewable plants are ready or not? So that has to come from some other communication network which you are making or which you are creating with that generators or something like that. So eventually you have like lots of hands in your body, and every hands are basically grasping information from different sources, and you yourself is the control center running the optimization and ultimately meeting the real-time demand. So if there is no communication channel working in real time, you cannot basically address these renewable energy fluctuations immediately. So you have to then basically conservatively integrate your renewable. You can still integrate renewable, but that will be a conservative approach, very safe side approach. But if you want to, let's say 100%, 90% renewable, then you have to have real-time mechanism through that communication channel. And that communication channel runs through lots of things. I've already shown WAN, LAN, HAN, and I just gave you an overall view. But if you have to go in depth of that how everything works and get that.
I can see Taskin raising hand. Taskin, if you could unmute and ask your question.
Assalamu alaikum, sir. Hope you're doing well. Yes, sir. Sir, I had a very small question. Like you said that you did your thesis regarding this topic of smart grids back in your days, like 10 years ago, and to see how far it has come today. So my question is, like, what is the prospect you see going into the future, like in terms of real-time implementation rather than only the research? Just I'm saying that implementation in general or in widespread way, like more action rather than research. How do you see its prospect in the future?
This is a very interesting question. Yes, we are. I think we move slowly. We move slowly, but eventually we get that. So how to say it. Let's say when I was in Thailand back in 2010, the BTS train station or those what we call it, BTS trains and something like that. Those were very common, but
Yes, sir.
this is now becoming common after 10 years in Dhaka city.
Yes, sir.
In 2014, 15, 16, Thailand has already implemented the pilot project of smart grid, and they have some communities already by now they are fully functional. And I'm very happy to share that one of the guys was my classmate, who actually is now working with this smart grid initiative as an entrepreneur. He did his PhD from Virginia Tech under Professor Saifur Rahman, but we did masters together, and then he is basically leading some projects in Thailand. So after 5-7 years, we now here seeing that okay, there is something going on, rollout of meters and some other things that I have shown.
Yes, sir.
I guess next 5 years, maybe by 2025, there will be something that we can call that, okay, we have some portions of Dhaka city adopting some concepts of smart grid, at least smart metering, I should say, if not demand side, if not anything else. But on top of that, if I say these things, the growth is, the rate we are developing is faster than before. So though I'm saying 5 years, maybe we can see it within 3 years.
Thank you, sir.
Thank you, sir. Now I would like to give the floor to Sanjana Tabassum. She is the PES Days Ambassador for 2021 from IEEE IUT Student Branch. Sanjana, can you listen to me?
Yeah, I can.
Yeah.
So, yeah, I will be concluding today's session. So, thank you very much to the speaker, Dr. Taskin sir, and also Zarif and the IEEE SB members who worked very hard to put together this webinar. A little background on PES Day. I don't want to bore you too much, but that's what I was chosen for, so to make you acquainted with the PES Day. So Power and Energy Society of IEEE was rebranded 12 years ago on April 22. That's why every year on April 22, we celebrate PES Day with a specific theme in mind. This year's theme was Clean Energy Revolution. Now we already know what clean energy means. It means energy that has minimal amount of adverse effects on the environment. And Sarah already talked about smart grid. So I'm not going to sit here and market the importance of renewable energy sources, because one day the fossil fuels will run out and renewable sources will speak for themselves that day. So I don't really need to go and market that. I just want to say that if this is your research area, then you should start looking into it now, because the prospects are great. Even if it's not that great in Bangladesh right now, it's going to be really huge in the future. And another important thing that I would like to say is I am in the PES ambassador group, and there every student branch posts their competitions and their webinars. If I find something interesting, I do try to post them in the IEEE student branch group on Facebook. So a lot of you have been competing in these competitions and have been doing incredibly well. A lot of you placed in top 3 of those competitions with student branches from all over the world. And I wanted to say I'm very proud of you guys. So keep an eye out for the competitions, and I can conclude today's session with that.
Thank you, Sanjana. And I would like to conclude by saying a grateful thanks to our keynote speaker, Dr. Taskin Jamal sir. It was a really, really insightful presentation. I hope all the participants learned or will have gathered some insights and research interests from your presentation. And I hope that in 5 years, the smart grid technology will be present in Bangladesh. Let's be hopeful. And it will replace the infrastructure of the current grid in the future, so that the utilities can serve the customer to provide the electricity needs. At this point, I would like to request all the participants to open up their cameras so that we can have a photo session.
Well, thank you very much, everyone. Maybe before closing the session, I should say something. So as an IUT alumni, it's a pleasure for me to present something in front of IUTians and the audience who are joining from outside for a program of IUT. It's always a it's an honor for me actually, and I'm really thankful to the IEEE IUT Student Branch and Sanjana and Jari for continuously being in touch with me and managing all these things, and all the teachers who basically supported this branch throughout. I think 2008, we were the first batch basically started doing something publicly for IEEE Student Branch in IUT. I was just going through the photos that day. So yeah, after 12 years, now I'm presenting in front of IUT IEEE Student Branch. That's amazing. And thank you very much for your questions as well, for the interesting questions, and hope to hear from you again. Thank you, audience, as well.
So we can wait for a photo session, 2 minutes. So one of the members, please do take snap of all the, I would request all the participants to open their cameras, first of all. If you are done, please let me know. So yeah, that's it. It's a hard time. We are facing harder times every day. We are facing deaths of many close ones and many family members and relatives. So it's a pretty hard time for us. But let's hope for some good things ahead, if it possible, if it's a blessing from Allah subhanahu wa ta'ala. For that, we have to maintain the social distancing. So last but not the least, let us wear masks. And there is the lockdown coming on from 14th April. So let's stay safe inside our homes and keep all our family members safe for the own good sake of us. With that, I would like to conclude this session. And also, Dr. Taskin Jamal sir, thank you once again. Rakibul Hasan Shagor sir has said regards and kind words for you. Thank you, and hopefully we'll have you in next year's sessions for PES Day or any other kind of power and energy related sector webinars. Thank you.
Thank you very much. Stay safe, everyone.
Assalamu alaikum.